Hey guys, have you ever heard that lobsters are basically immortal? Like, they just keep growing forever and never get old or weak. It's one of those mind-blowing facts that floats around the internet. But is it actually true? Today, we're diving deep into the weird, fascinating world of lobster biology to uncover the truth. Spoiler, they're not immortal, but they're pretty close in some wild ways. Stick around, because this could change how you think about aging, not just for lobsters, but maybe even for us humans. Let's start with the basics. American lobsters, the ones you see on your plate, can live a ridiculously long time. The record holder was caught back in 1977 off Nova Scotia. Over 44 pounds, about a meter long, and estimated to be over 100 years old. Imagine that, a creature older than your grandparents, still kicking on the ocean floor. Most animals slow down as they age. They get weaker, less fertile, more prone to disease. That's senescence, the biological decline we all associate with getting old. But lobsters? They don't do that. Older lobsters are often bigger, stronger, and even more fertile than younger ones. They keep growing their whole lives through a process called indeterminate growth. No stopping point, no adult size like us. How do they grow? Molting. Lobsters have a hard exoskeleton that doesn't stretch, so to get bigger, they shed it like a snake sheds skin. Young ones molt several times a year, but as they get huge, it happens less often, maybe once every few years. Right after molting, they're soft and vulnerable, easy prey. But once the new shell hardens, they're bigger and tougher. The catch? Molting takes massive energy. The bigger the lobster, the more energy it needs to reabsorb calcium from the old shell and build a new one. Eventually, for really giant ones, the energy cost becomes too high. They can't accumulate enough reserves between molts, get stuck in their shell, become vulnerable to disease or exhaustion, and that's often how they die. Not from old age as we know it, but from the sheer physics of being too big. So, that's the paradox. Lobsters have tricks to avoid typical aging, but their lifestyle ultimately limits how long they live. Now, let's get to the cellular level. This is where it gets really cool. In most animals, including us, cells have a built-in limit on how many times they can divide. It's called the Hayflick limit, tied to these things called telomeres. Telomeres are like protective caps on the ends of your DNA strands. Think aglets on shoelaces. Every time a cell divides, telomeres shorten a bit. When they're too short, the cell stops dividing or dies. That's a big part of why we age. Tissues can't repair themselves forever. But lobsters? They produce an enzyme called telomerase in most of their body tissues, not just reproductive or stem cells like in humans. Telomerase rebuilds those telomeres, letting cells divide indefinitely without shortening. Studies from the late 90s confirmed high telomerase activity in lobster organs, allowing constant renewal. Rhetorical question. If unlimited cell division usually leads to cancer, why don't lobsters get tumors all the time? Turns out, their genome, fully sequenced a few years ago, has extra copies of tumor suppressor genes, like multiple backups of p53, the guardian of the genome. Plus, enhanced mechanisms to silence dangerous DNA regions. Cancer is super rare in lobsters. They've evolved a balance. Indefinite cell renewal without the cancer risk that plagues longer-lived animals. What about reproduction? Females only mate right after molting, when they're soft. Older females produce way more eggs, up to 100,000. But as molting slows with age, reproduction does too. Still, no drop in fertility from cellular aging. Scientists even developed ways to age lobsters accurately now, using DNA methylation like an epigenetic clock. It helps manage fisheries sustainably, protecting those big breeders. So, wrapping this up, lobsters aren't truly immortal. They die from predation, disease, or mostly that exhausting molt when they're massive. But they dodge senescence, no weakening, no cellular decline. They're a natural experiment in what life without traditional aging looks like. This stuff has big implications. Understanding lobster telomerase and cancer resistance could inspire human longevity research, better tissue repair, lower cancer risk. Who knows? Maybe one day we'll borrow a trick or two from these ocean tanks. What do you think? Would you want to live like a lobster, growing forever until physics says no? Drop your thoughts in the comments. If this blew your mind, hit that like button, subscribe for more deep dives into weird biology, and turn on notifications so you don't miss the next one. Thanks for watching. See you in the next video. Peace out.